Good morning, students. In the last lecture, we end our fifth chapter, oscillation. Today, we are going to start new chapter, chapter 6, which is superposition of waves. Now, today, we are going to discuss the introductory part of this chapter, superposition of wave. Means, what is wave, what are the types of wave, and some properties of the wave. Okay, now, first of all, we need to understand a word wave. What do you mean by wave? You are familiar with the word wave. Light wave, sound wave, mechanical waves, electromagnetic waves. These are the types of waves. In these waves, wave is nothing but the disturbance due to the vibration of particles of the medium. For example, consider these are the particles of the medium and they are at the equilibrium position when there is no disturbance. Okay, when there is no light, when there is no sound, all is silence, then the particles of the medium are in the equilibrium position or they are in the mean position. But as soon as sound or light is travel to the medium, the particles of the medium vibrate about its mean position. They vibrate about their mean position. This is the mean position, and these particles are vibrate like this. They vibrate about their mean position in up and down. Okay, or in the to and fro. So, such type of motion in which there is a disturbance of the particle of the medium, such type of motion is called as a wave motion. It is simply called as a wave. In wave, what happens? In wave, the energy is transferred from one point to another point, from one place to the another place, but there is no migration of particles. The particles remains at the same place when they are at the equilibrium position, at the initial position. They do not move from one place to another place, but can transfer energy from one place to another place. So we can say that this wave is nothing but a mode of transfer of energy from one place to another place without the migration of the particles. Migration means these particles are not traveling from one part to another part, they are at their equilibrium or the original position. So this is the wave. Wave is nothing but a disturbance of the particles of the material through which the wave is traveling. Now, what are the types of waves? Waves, mainly we are discussing here two type of waves. Waves, and these waves we are discussing in this chapter. It is a mechanical wave, and second one is called as the electromagnetic. So, what is the difference between these two type of waves, mechanical wave and electromagnetic wave? So, in the case of mechanical wave, to transfer or to travel this mechanical wave, there must be a medium is necessary. Okay, without medium, this mechanical wave can't travel from one place to another place. For example, which type of waves we can see that it is a mechanical wave? Sound wave is a mechanical wave because sound required some medium to travel from one part to the another part. Okay, so what is the main property of this mechanical wave? This mechanical wave need material medium. Okay, and what is the example of this? The example of this is sound wave. Okay, which needs the material medium. Now what is the electromagnetic wave? Electromagnetic wave is the wave which does not require any medium for the traveling or for the transfer from energy from one point to the another point. So you can say that this electromagnetic wave can travel from one place to another place without medium. Okay, and what is the example of this? The example of this electromagnetic wave is nothing but a light wave. Okay, so these are the two types of waves we are going to discuss in this chapter, superposition of waves. But mainly we are concentrating on the mechanical waves. Okay, so what is mechanical waves? What are the properties of mechanical wave? We are going to discuss here. Okay, so first of all we see what is the progressive wave. As name indicate, progressive wave means a wave which travel in a given direction without any obstruction, without any damping. Such type of motion is called as a progressive wave. Such type of wave is called as a progressive wave. Means a wave which is traveling from one point or one place to another place without losing energy. Such type of wave is called as a progressive wave. Okay, and when this progressive wave takes place, there are some properties of the progressive wave we are going to discuss here. So first of all, we need to see the definition of this progressive wave. What is progressive wave? A wave which travel from one part to another part, from one place to another place without any destruction, obstruction, obstacle, and any damping, without losing any energy. Such type of wave is called as a progressive wave. And these progressive waves are again differentiate or again uh, divided into two parts: longitudinal wave and a transverse wave. We already discussed this longitudinal wave and transverse wave in 11th standard. So here we are going to see the properties of the progressive wave. In the book on page number 131, you have given properties of progressive wave. We are going to discuss one by one. So the first property of this progressive wave is, okay, so the first property is each particle in a medium execute same type of vibration. Particle vibrate about their mean position performing simple harmonic motion. So what is the progressive wave? In the case of progressive wave, the particles of the medium vibrate with the simple harmonic motion. We discussed in the earlier chapter what is simple harmonic motion. So when a progressive wave is traveling from one place to another place, all the particles are traveling with the same type of motion, same type of vibration, and this vibration or this motion is nothing but the simple harmonic motion. Okay, so this is the first property of the progressive wave which state that all the particles of the medium perform same type of motion and they perform a simple harmonic motion. What is simple harmonic motion? The motion in which force is always directly proportional to the displacement and directed towards the mean position. Okay, so such type of wave is called as a progressive wave. Now we are moving towards the second property. Second property state that all vibrating particles have same amplitude, same period and same frequency. Same amplitude, same period and same frequency. What do you mean by amplitude? So consider here, these are the particles which are performing or through which a progressive wave is traveling. They are performing a simple harmonic motion then the maximum displacement of the particle, the maximum displacement up to which the particle can travel in the upward direction in the two or flow motion, such type of displacement is called as the amplitude. So we can say that this is the amplitude and this is again the amplitude of this progressive wave. And when a progressive wave is traveling through a medium, its amplitude remains constant. Its amplitude doesn't changes. Because we earlier say that energy remains constant and energy in the simple harmonic motion is proportional to the square of the amplitude. So if this amplitude remains constant, means the energy of this progressive wave also remains constant when it is traveling from one place to the another place. Okay, now it has same period. Same period means the time required to complete one vibration. One vibration, to complete one vibration, this time is called the time period. Everywhere at any place during the progressive wave, the time period is always remains constant. As the time period remains constant, its frequency also remains constant. What is the frequency? Frequency is nothing but the number of vibrations completed in 1 second. So these three terms, amplitude, period and frequency, they remains constant in the case of progressive waves. Okay, we are moving towards the third property. Third property is the phase changes from one particle to another particle. Okay, what is the phase? If the first particle is try to move in the upward direction, the next particle try to move in the downward direction. So we can say that there is a phase 180-degree for the neighboring particles. If these are the two neighboring particles, then they are out of phase, or there may be a phase change during the two neighboring particles. If we consider another neighboring particle to this, so this is the vibration of the particle in the upward direction. So in this way, two neighboring particles always in out of phase, means their angle of vibration is always opposite to each other. Okay, if it is in the upward direction, the next particle must be moved in the downward direction. To balances the reaction, to balances the energy consumption, these particles are vibrate with the opposite phases. The neighboring particles vibrate with the opposite phases. Okay, we are moving towards the next property, fourth property. What is the fourth property? No particle remain permanently at rest. When a progressive wave is traveling through the medium, the particles of the medium are not permanently at rest. They are rest for very small time when they are at the extreme positions. Okay, when these particles performing such type of motion about the mean position, their velocity is equal to 0 for a very short interval of time when they are at the extreme position. What are the extreme position? We learned that during the simple harmonic motion, this is the mean position and these are to the extreme positions. Okay, so when this particle is at extreme position, either extreme position, upper, lower, left, right, okay, at this extreme position, the speed of the particle or the velocity of the particle is 0 for a very short interval of time, for a very small time. Okay, so they are permanently not at rest, but they at rest or they stationary for a very small interval of time when they are at the extreme position. This is the fourth property of the progressive wave. The particles attain maximum velocity when they cross the mean position. Now, if these particles have minimum velocity at the extreme positions or zero velocity at the extreme position, it means the velocity of the particles at the mean position is maximum. When this particle is traveling from this extreme position to this extreme position, it crosses the mean position with a very high velocity as compared to the extreme positions. So when the velocity of the particle is maximum, it vibrates with the maximum velocity when it crosses the mean position. When it travels from extreme position to the mean position, its velocity increases. At this place, at the mean position, it is maximum, and as it travels from mean position to the extreme position, its velocity again decreases, and here it becomes zero. So the velocity changes during this motion, in which at the extreme positions it is equal to 0, and at the mean position it is the maximum value. Okay, so next, during the propagation of wave, energy transfer along the wave. When the progressive wave is traveling through the medium, only the energy is traveling from one point, one particle to another particle, and in this way it travels from one place to another place. Okay, so in this way, in the progressive wave, only energy is traveling, energy is transferring from one place to another place. The material or the particles does not move from their original or initial places. So only energy travels, the particle remain at their original positions. Okay, so this is the sixth property. The seventh property say that the wave propagates through the medium with a certain velocity. This velocity depends upon the properties of the medium. Okay, so when this progressive wave is traveling through the medium, it travels with some velocity. It propagates with some velocity in the forward direction, and this velocity is depend upon the property or the nature of the medium through which this progressive wave is traveling. For example, through the liquid, through gases, or through the solid, each time the progressive wave travels with the different velocities, because the properties of solid, liquid and gases are different from one another. So as the material medium changes, the velocity of the progressive wave also changes, or we can say that the velocity of the progressive wave is depend upon the properties of the material through which it is traveling. Okay, this is the property of the progressive wave. Now next, progressive waves are of two types. Okay, progressive waves are of two types. The first type of progressive wave is nothing but a longitudinal wave, and the second is transverse wave. Okay, these are two types of progressive waves. Okay, so what is longitudinal wave and what is transverse wave? The wave, the progressive wave, in which material medium vibrate along the direction of propagation of wave. For example, this wave is traveling in this direction, so the particles are also vibrating in the same direction. Such type of progressive wave is called as the longitudinal wave. Okay, and what is the transverse wave? The wave in which, for example, this wave is traveling in this direction, the particles of the medium vibrate perpendicular to the direction of propagation of the wave. So there is an angle 90 degree between the vibration of particles and the propagation of waves. Such type of wave is called the transverse wave. In the case of longitudinal wave, there are two types. Longitudinal wave consists of compression and rarefaction. One compression and one rarefaction give us one longitudinal wave. In the case of transverse wave, there is a crest and trough, and one crest and one trough gives us one transverse wave. Okay, so these are the two type of progressive wave. They are distinguished from each other on the basis of vibration of the particles. Either they are parallel to the direction of propagation, either the direction of the perpendicular to the propagation of the wave. So these are the two types of progressive wave. Next, both transverse as well as longitudinal waves can propagate through the solid. It means longitudinal wave and transverse wave, they both travel through the solid. They travel to the solid. Longitudinal wave as well as transverse wave, they can travel through the solids. But only longitudinal wave can propagate through the fluid. What is fluid? Fluid means the substances which can flow. So fluids, longitudinal wave can pass through the fluid. Transverse wave can't flow through the fluid. Okay, so this is the next property which state that longitudinal wave and transverse wave both, they are traveling to the solid, but only longitudinal wave can pass through the fluids, that is liquid and gas. Okay, so these are the properties which are given to the in the page number on the page number 132. We are going to see here the introduction of the superposition of wave. In the next lecture, we are going to see what is the equation of this progressive wave. Progressive wave represented by which equation, we are going to see in the next lecture, as well as we are going to see the reflection of waves. Reflection of wave means when a wave is traveling, or when a wave is along the path is traveling and obstacle come before him, so what happens, it gets reflected. So what is the reflection of waves? Longitudinal wave and the transverse wave, we are going to see in the next lecture. So in this way, in this lecture, we discuss about the introductory part of this chapter, superposition of wave and some properties of the progressive wave. In the next lecture, we are going to see the reflection of waves from rarer medium as well as the denser medium. So this is for today. Have a good day. Bye.